Today we are going to simplify complex fractions. Step 1. You have to create a single fraction in the numerator, if necessary. Step 2. Create a single fraction in the denominator, if necessary. The main fraction line means divide, so you can rewrite it if you choose to do so. Step 4. Follow the normal rules for dividing, which means that what we did yesterday, keep, change, flip, and then simplify if necessary. So looking at our first example, in our numerator we do just have one fraction. In our denominator we also have one fraction, so the first two steps are done. This little line in the middle does mean divide, so we can rewrite it, or we can go right to step 4, which just says do a keep, change, flip. So we can keep the numerator the same. We can change that division sign to multiplication, and we can flip the second fraction. And from there we reduce. 5 goes into 5 once, goes into 5 once. 2 goes into 6 3 times, goes into 8 4 times. We are left with a 1 times 3 is 3, 1 times 4 is 4. So 3/4 is our final answer. The next one is also pretty easy because we can skip the first two steps. And we can go to step 3 or even step 4 at this point, where we do a keep, change, flip. Alright, so I'm going to keep the first fraction as 1 over 2x, change the division sign to multiplication, and flip the second fraction to 3x over 6. From there I'm going to cross off what I can. I have x's can cross off. 3 goes into 3 once, goes into 6 twice. Nothing else I can cross off, so I multiply. 1 times 1 is 1, 2 times 2 is 4. And that's it there. For our next example, we start getting a little more difficult because we can no longer skip steps 1 and 2 that we have up here. Alright, so we have a plus 1 over a over 8. That denominator is just one piece. We're okay. It's that numerator we have to deal with. What you can do is, I'm going to just cross this off. You can call that a over 1 as opposed to just an a. Then you look for a common denominator between 1 and a. That common denominator is going to be a, so the first piece I need to multiply by an a. A times a is going to be a squared. Second one is fine, it already has an a in that denominator. So it'll be a squared plus 1 all over a. And the denominator is just an 8. You have one fraction in the numerator, one fraction in the denominator. Because this 8, you can think of it as an 8 over 1. So we can do a keep, change, flip now. A squared plus 1 over a is going to stay the same. Change division to multiplication. That's an a. And then this 8 over 1 is going to change to a 1 over 8. Cross off what you can, which is actually nothing. So what you multiply across, a squared plus 1 times 1 is a squared plus 1. A times 8 is 8a. You cannot cross off the a squared and the a because remember the a squared is combined by the plus 1. Looking at our next piece, we have to do both steps 1 and step 2 because we do not have one fraction in the numerator and we don't have one fraction in the denominator. So if I look at the numerator first, the common denominator there is going to be 2 times a. So the first one needs an a. The second one needs a 2. A times a will give me a squared. 8 times 2 is 16, so minus 16 over 2a divided by. Now if I look at that denominator, common denominator between 4 and a is 4a. So the first one needs an a, second one needs a 4. A times 1 is a, minus 4 over 4 times a is 4a. Now it looks a little better. We can do a keep, change, flip. We can also factor what we can. A squared minus 16 does factor to a plus 4a minus 4. Oops, that should be an a. Let me get rid of that. Over 2a. Division goes to multiplication. Flip your second fraction, nothing factors there. Cross off what you can, which is our a minus 4's. A's, 2 goes into 2 once, goes into 4 twice. So I will be left with in the numerator 2 times a plus 4. Denominator is just a 1, so you don't even need to write it because it's just a 1. One more example, it's just written a different way, but it's the same thing as we were doing before. The left-hand side represents like the numerator. The right-hand side represents like the denominator. Now, if I look at this, it's not common yet. The common denominator between x squared and x cubed will be x cubed because you need to have 3 x's is what it's saying. So I'm going to multiply that first by an x, just one x to get it to an x cubed. When I do that, I'm going to get 3x plus 5 over x cubed. Now on the other side, that's like a 6 over 1. Common denominator between 1 and x is x. So I will have 10 plus 6x over x. Now this is a division problem like yesterday, so I'm going to do a keep, change, flip. Let me see if I can move down a little bit. Okay, I don't have a lot of room left, but I will do a keep, change, flip here. I will have 3x plus 5 over x cubed times, flip this one, x over, and I do have a GCF there. GCF is a 2. And when I take the 2 out, I'm left with a 5 plus 3x. You hopefully should notice that 5 plus 3x is the same as 3x plus 5. You have 1x in the numerator, can cross off with one of the x's in the denominator. In the numerator, you crossed everything off. You cannot call it a 0, but you can call it a 1. X squared and a 2 is left in the denominator, so that's 2x squared. And that's your final answer there. We will do the rest of this tomorrow in class.